Thank you. So I'll be presenting derivatives of ethacrynic acid as potential anti-metastatic drugs. I'll begin my presentation with a brief outline where I will explain what ethacrynic acid is, which will then lead to the purpose of my project. I will then show some results, and finally I will leave with my conclusion and some ideas for future work. So, what is ethacrynic acid? Ethacrynic acid is a compound that has been used for a couple of projects, and in view of what it does on cancer cells, there is not a lot known except for some publications by Zhao's group, which state that it inhibits the growth of cancer cells, but only at very high concentrations. Recently, our corroborator, Dr. Janser, published that ethacrynic acid, which lacks the alpha-beta unsaturated carbonyl unit, can inhibit the growth of breast cancer cells, and this can be observed at concentrations which are not at all toxic to our cells. So, given our previous result, new derivatives of ethacrynic acid were synthesized by Dr. Janser's group, which lacked the alpha-beta unsaturated carbonyl unit, the part thought to be responsible for a diuretic effect. So, in order to further in our structure-activity relation studies. Besides that, this project has allowed us to better understand the mechanism for invasion and formation of metastasis, and to identify potential targets to test our new derivatives. So as it was explained previously, in this project we are using the HS578T breast cancer progression model, which consists of the HS578T parental and its derivative, the HS578T invasive. There are some similarities between these two cell lines, as was explained. Our HS578T is estrogen independent, and we decided to use the MCF7 AZ cells dependent cell line in order to see if they would interfere with the activity of the estrogen receptors. So, similar to what Maylene presented for the attraction fractions, we decided to do a tremendous amount of MTT assays in order to determine the toxicity for each of our compounds. We begin our project by treating our cells with increasing concentrations ranging from 1 to 100 micromolars in order to determine the toxicity for growth and migration, which I will show later on in my talk. Okay, since there was a limited amount of time, I won't be able to show you all of our graphs, so instead I'm presenting you with the OD80 IC20 table. Now, when we have a look at our compounds in general, we can observe that they're less toxic than ethacrynic acid on all of our cell lines. And another important observation is that all of our compounds seem to be less toxic towards the MCF7AZ cells, and that our first 8 compounds are more toxic towards our HS cell lines than the rest of our compounds. So, similar to our previous graph, in our present graph, we can observe that ethacrynic acid, again, is more toxic towards all of our cell lines after 24 hours of treatment, and that all the compounds are less toxic towards our MCF7AZ cells. And again, the first 8 compounds are more toxic towards the HS cell lines in compounds 9 through 25. Now, when we take a closer look at compounds 4 and 7, we can observe that they both have the carboxylic acid side chain just like ethacrynic acid, and that they have the carbonyl side group. But unlike ethacrynic acid, it is an unsaturated one. Now, when we take a closer look at compounds 60 and 20, we can observe that these compounds are more simple in structure than our first 8 compounds, and that they lack the carboxylic acid side chain, like as ethacrynic acid has. But compound 16 lacks the carbonyl side group. So, what we can conclude is that the carboxylic acid side chain is responsible for the more toxic effects on our HS cell lines. So, after determining the cytotoxicity for each of our compounds, we decided to continue with our first biological assay, the sulforhodamine B, which, as was explained by Maylene, this assay stains for proteins in the cells and is a measure of the amount of cells. So, in other words, this assay allows us to determine if the compounds are taking some sort of effect on the cell line. Again, in this assay, we also treat our cells with increasing concentrations. I'll be showing my results in both a graph and a table. In this table, after 24 hours of treatment, we can observe that ethacrynic acid influences all of the cell lines. But for the rest of the compound, there is no growth inhibitory effect observed until 100 micromolars. And for this graph, after 72 hours of treatment, we can also observe that ethacrynic acid again influences all of our cell lines. But here, there is a small growth inhibitory effect observed for some of our compounds after 72 hours of treatment. So, here we plot our results using our OD80 IC20 concentrations, and this is what we obtained. Overall, we can observe that our compounds are not toxic towards our cells, but ethacrynic acid does show some inhibitory effect around 30 to 40%. With this graph, what I really want to point out is that not only are compounds not toxic towards our cells, that they also don't inhibit the growth. Also these compounds are ideal candidates for potential anti-metastatic drugs. Okay, so I want to begin by showing you some pictures for a wound healing assay for the MCF7AZ cells. As Natalia explained, we begin this assay by wounding the cells' layers. We then measure them at time 0. Then we treat these cells and allow them to grow over a period of time. The time depends on the cell line being used. And for the MCF7AZ cells, that is between 24 and 72 hours. So it is clear from these pictures, at time 0, and then after 24 hours, we can observe that the cells' inner control migrated to a similar extent, being around 1,600 micrometers. And that after the cell's inner control migrated to a similar extent, which was not observed for compound 12. In other words, compound 12 seems to inhibit the normal migratory effect of our cells. This graph represents data obtained after 48 hours of treatment, using the concentrations for each of our compounds. And the ability to inhibit migration is expressed as the distance in which cells migrate. In my previous slide, I showed you some pictures for compound 12. But from this graph, we can observe that both compound 4 and 15 also inhibit the growth of our cells. For the HS cell lines, we also did similar experiments. For example, we began by taking some pictures of the compounds that were able to inhibit the normal migratory effect. And on our left, we have our control at time 0 and then at 6 hours. And on our right, we have compound 4 again. Again, we can notice that the cells migrate to a similar extent. But after 6 hours, we can observe that the cells in our control migrate much more faster than our cells being treated with compound 4. Another example on this cell line is compound 10. When we compare compound 10 to other prospective compounds, we can observe that compound 10 is able to inhibit the growth of cells to a similar extent. In fact, we were able to test this compound on the HS cell lines, and our results are present in the following graph. Again, our results here are presented as the ability to inhibit migration. Here we can observe that compound 4 and 10 are able to reduce the migration distance by more than 50%, as compared to our untreated compounds, which do not inhibit the growth of our cells. Although a lot was already done for this project is not completely done yet. We can conclude that compound 4 is able to inhibit the growth of our cells, and this is observed at non-toxic concentrations of compound 4. Besides this, we were also able to observe that the toxic effect that was observed in some of our compounds can in general be ascribed to the carboxylic acid side chain. Of course, our first bullet for future work will be to continue with our wound healing studies and try to determine a relationship between structure activity and ability to inhibit migration. Besides that, compounds that stand out, such as compound 4, can be further used for functional assays and mechanistic studies in order to determine the mechanism of action for our breast cancer progression model. I would like to thank Dr. Van Slamberg, Dr. Steelen, Melissa Candelaria, New Mexico Tech, St. Thomas University, and my lovely lab partners.
you saw that one of the compounds that you tested affected migration.
Mm-hmm.
So what molecules would you, how would you go about testing, hypothesizing what molecules are involved, what molecules your compound affects, basically?
Mechanistically?
Okay.
Proteins and lipids, you mean the targets? What you ask for is like, what techniques would you apply, or what methods would you use to investigate how they work now,
Oh,
right?
okay. Well, that wasn't part of our study. We just tested the compounds using our wound healing study.
No, I know.
Okay.
Think about Natalia's work,
Okay.
right? And how she studied different proteins involved in the process, right? And you found a compound that affected migration. So what proteins would you test to see if they were being affected by the process and causing the migration defect?
Remember what I showed you with Zach's work from last year?
No. I'm sorry, I can't answer your question.
Her project was based on testing different chemical compounds. My project was based on several different molecules, and a type of molecule that is involved in the migratory activity of these cells is the molecule called integrin.
Right. So could you test whether your compound affects integrins?
Well, that's what we're doing. Yeah.
That was the question.
Oh, okay. Any more questions?
Why did you choose to use ethacrynic acid?
Well,
Was it the first ending?
It was forced on.
there was what?
It was forced onto you.
Oh, I'm sorry.
No. It's our collaborator. He came up with the idea of using ethacrynic acid and derivatives.
Well, there was also the studies that we found that for the leukemia cells, and then based on that we involved
Yeah.